if you remember the steps, I think there's plenty of white space on the test for you not to have to use sticky notes. So we're going to just follow the procedure. I'll move this over here. And first step was to change the function notation to a y. Oops, I got my camera zoomed in too much here. Then you switch the variables. And then you gotta oh, pickles. I made one X and made the other X. Liar, liar, pants on fire, right there. And then you get to solve for Y. So to untangle this algebraic expression, you've got to remove the 2 that's being subtracted first, because if you cube both sides before you add 2, then you got a pretty messy expression. Okay, so it's x plus 2 is the cube root of y minus 2. Remember, you can't touch what's in here until that cube root disappears. So you'll cube both sides. That's the inverse of cube root. So you end up with the x plus 2 cubed is y minus 2. Adding 2 to both sides. And my inverse function for the original one written here is quantity x plus 2 cubed plus 2. Okay. So here comes the common sense. You will have, when you begin, your result is going to be the inverses of what you see. So you should have a plus 2 and a plus 2 in the answer, you see. Oh, there's not a plus 2 in this answer, not a plus 2 in this answer. There's no plus 2s in that answer. And yep, this one matches exactly. So you've got your inverse operations for the 2's that were being subtracted and your inverse operation for your cube root, which is cubed. And the graph is just to help you remember what a graph and its inverse look like. So if you want to, you could draw that diagonal line of symmetry to affirm this is the right inverse function. Remember, this is the x equals y graph or y equals x line. It will fold across. If you fold this, it's perfect. Now, it's perfect in some of the others as well, but it didn't have the right inverse operations and values. Okay? So you see where common sense is going to help you tremendously. The distractors on this example of the test are pretty obvious. Pretty obvious which one's the right one, which ones are wrong. Okay, so this is the first 5 we've got to do, and you can do the algebra and then affirm with your common sense. And that's what I like about math. You know, if you follow the idea, hopefully it's not like a shot in the dark. It's complete common sense. So here we've got. We're going to rewrite it as y equals x plus 1 quantity cubed. Then we'll switch our 2 values. So x equals y plus 1 cubed. I'm going to have to go off on the side here. Then I get to take the cube root to remove that cube sign. So I'll just put the cube root of x equals y plus 1. He's out free and clear. And the last step is we take away the 1, which is found outside the cube root operation. And that's our inverse. So I should have a cube root. Oh, it looks like it's A. Okay. Did I circle that one on number 1? Let's see. I didn't. I'm sorry. I needed to circle D just to, validate what I found to be true. Okay, go back to number 2. Circling A out. I can see that my graph is symmetrical. And if I started adding 1, I need to subtract 1. B didn't have a subtract 1. C didn't have a subtract 1. And D, there was no dividing by 2. There was no multiplying by 2, so there wouldn't be any dividing by 2. So, that is the game you play. So you rename, switch, solve for y. Write it as inverse function. Now on my software, I had to tell it to give me powers bigger than squared, and that's why this 5th power shows up here, this 5th root. But it's no different than a 3rd root, or a 2nd root. It's just the inverse of a 5th root is to the power of 5. So your answer, your inverse answer, okay, I'm going to write it here, is y equals 5th root of x over 2. So switch those two. X equals 5th root of y over 2. And then to remove the 5th root, you just take it to the 5th power. So it's x to the 5th is y over 2 free and clear. Make it a little messy, a little less messy. Multiply both sides by 2, so 2x to the 5th is my inverse of g. Okay, so inverse of a 5th root is not a 3rd root, obviously. Again, inverse of a 5th root is not a 5th root. It's got to be the power versus the root. Bless you. It looks like C is that, because it's the 5th power and it's multiplied by 2. And D again, the inverse of a root doesn't stay a root. So that's hopefully, if you haven't done 10.1, dig in. You might get it now. That's all, if you got the steps, you can get the work. Okay? Don't sell yourself short. There are boundaries, on square root functions. Maybe that's what you're scared of, the domains and ranges, which this didn't ask, the software didn't have that for me to ask you about. So if you can identify the graph, you should be able to then understand the boundaries. Like this one has no boundaries, obviously, right? Because it's an odd function, and I don't know if you remember that from our homework, that odd functions have no restrictions. Yes. Okay, again, a 5th root. So I'm going to go ahead and write my inverse, because I know the opposite of add is subtract, and the opposite of a 5th root is a 5th power. So how do I know if this subtracts in or out? Well, I'd have had to move this first, so we would have been next to the x first. So 5th root doesn't have a 3rd root inverse, not a 3rd root inverse. C is the answer, because it went to the 5th power. And D, you don't invert and root to get a root. So whoever wrote these distractors just, if you were paying any attention at all, get your homework done, you should be A+ on these first 5. I like inverses. They make, they're clear. The inverse operations. That's what we're practicing on. Something you learned very young. I think around in middle school or before, when you had to, when you knew all 4 operations, then you knew how they were related. Big deal. Okay, this one's a little messy because I'm not sure where things end up, inside or outside or upside down. So I'm going to go ahead and write y equals x plus 2 cubed plus 3. I'm going to switch these two. X equals y plus 2 cubed plus 3. It looks like the 3 gets moved first by subtraction. So it's x minus 3 equals my quantity cubed. The inverse of cube is root. So this guy all is under the cube root sign. He's an inside, so nobody can touch him now. So when you move the 2 over, you can't take -3 minus 2. You've got to do the cube root of x minus 3 is one term, and then subtracting 2 is on the outside. This is an F. So that the only closest one, somebody might pick this one thinking you could mess with the 3 and the 2, but you can't. So it's not the 5th root like C, it was always a 3rd, and it's not the 5th power like D and B. It's got the wrong, you can't see what I'm doing here. Yeah, B, you can't touch those 2 with each other, so it has to be A. It's exactly what we found when we did our math. Let's see if I got a highlighter. Kind of lost in the scratch paper. Those 2 match. Okay? Now we're done with our inverses. Now we're going to do 10-2 and 10-3, which we did pretty much together last week. So if you missed a day, watch the videos, ask for help, get support into the examples, understand what you're doing, and you'll be good for the next 10 problems. Okay, a square root makes has an endpoint, HK, and it can be stretched, reflected, all that stuff. So the main thing is, can you find the endpoint from the equation? So H is here, K is here, H is crazy, K is normal, and this means stretch. Vertical. So you can count 3 up, 1 over from the end point. This is the end point of curve or whatever, square root function. That's where it starts. So this is H and this is K. So if there are more than one graph with the endpoint, then you look at the stretch. But start with looking for the endpoint. So it looks like A is the story. That endpoint there is a -1, -3. And if it's stretch 3, that means I count up 1, 2, 3 over 1. It's going to hit on the curve, and it does. So A is my solution. Let's see the other choices to make sure. If I try to find -1, -3, it's over here on B, so that's not the end point. C, -1, -3. That's not the end point. D, -1, -3. So the end point, and for my examples, you know, there was only one of them with that end point. So that's a good thing. Okay? So that's why we picked A. And that you two can do on the homework as well. You keep your eye on the prize. You got to talk a little bit more about it on the homework, but that's what will make this test. You earned your simple, earned your easy here. Okay. 7. This one, I don't know this one. One of them fooled me, but I don't think it was this one. 1, 2. That's a vertical stretch because it's more than 1. It's 3. And that guy makes a reflect across the x-axis. So that means instead of shooting up, it will go underground, shoot down. So I have to look for 1, 2. Okay, do you see how that one fooled me? I have to go 1 over 2 up. So that one almost fooled me. And, you know, when I see a graph like this, I panic and I think, did I read that right? Yes, I read that right. Remember, H is crazy, K is fine. Yeah. Okay. So 1, 2, I see that. And it's reflected across the X. If it wasn't, it would be going up like that, but it's not. It's going down and under. It's an underhand pitch. Okay. C, 1 over 2 up, nope. D, 1 over 2 up, nope. So we've got our winner, winner, chicken dinner. It starts at that end point, and then X gets bigger, but Y gets smaller because of that multiplier right there. He switches everything up. And we can count. If the multiplier is a -3, we go 3 down. 1, 2, 3 over 1. Bingo. It's in there. It exists on the curve. You can only do that for the first move. You can't. It changes because it's a square root. It's not a line. Okay. 8's a pickle because they have the K in a different place, but we're not afraid. All we have to do is rewrite it in our mind or on our paper. This also, this 1 is just a term I can put on the back side of my square root function. They're both on the same side, so the sign doesn't change. So I can rewrite this function as y equals -2 square roots of x plus 5, and then plus 1, because the negative stays with the 2. The 1 is a positive. You know, it's always the sign that's to the left of the number that goes with the number. So don't let that mess with you. It's okay. No worries, no worries. Just realize that flexibility in the form. So we just read it again. We get our H and our K, and then realize it reflected across X, which is nice because I think this software only has that one. I don't remember having that choice. I could reflect it across the Y, but we'll reflect it across the X. It's a beginning, you know. It's graphs, vertical stretch. Yep, no matter what the function is, we still have these ideas and they work. I'm going to go on -5, 1. It looks like A is it. -5, 1, -5, -5, 1, -5, 1. Yep, A is the 1. So this one has the -5, 1. and it swoops down. They're kind of mess with you. The only other close one is if maybe you switched up D. B's got negative or positive 5, 1. C has got positive 5, negative 1. All the crazy messes. Negative 1, negative 5. So, and I can count. It goes 1, 2, 1 over. See, it's on the graph. And the next one. Okay, back to, we don't have to rewrite it to see it. Negative 6, negative 3, H and K. There's no reflection, just vertical stretch. You do this enough, guys, you'll be experts. Have you put in your 10,000 hours? That's what it takes. Okay, this is both positives. There goes my folders. Oh well. This are, no, it's not a 1, 1. Where would they get that one, right? Negative 6, negative 3. That looks close, and it looks like it's the right one because that is not. And see where you could, if you don't know H and K, you'll get caught. It will be revealed, right? Stretch of 2, up 1, 2 over 1. Yep, that works. Not going any further. Here we go. Yeah, that was number 9. One more for the square root story. Kind of fun. I hope you're feeling the fun. If you haven't finished up your 10.2, please dive in and use what you were seeing on the review. Back up. Truth is truth. Yep. No reflection. Vertical stretch. 3, negative 5. Don't forget to remember that template. A square root of x minus h plus k outside. That's why this gets switched. You write what you see as being subtracted, and then k is what you see being added. I think I'll do it again, probably. Okay, so I'm looking 3, negative 5. So A, they got switched. 3, positive. 3, negative 5. Looks like it's C. And a stretch of 3. 1, 2, 3, 1. Yep. Use my value. You guys good at counting the stretches? I just, my version of the test happened to have a solo, a starting point there. That was the only choice. So, but I want to make sure that you're able to find the stretches. Okay? And D, they're both negative, and they weren't up here. And one of them is positive, so they've got the wrong one. And it's a good thing we're offline because it will be really more difficult to read the graphs. Okay, 11 through 15. Here's the story. It's a cube root, so no restrictions. So the graph will go both ways everywhere, but every way. But this is the dealio, guys. I don't know if you write it on your notes, but you got to change your brain. Instead of looking for endpoints, you're going to be looking for turning points. Like this one's the one that fooled me. So if it was me in the test, and I know myself and my test anxiety, I would find, see this one? That's what you just got done with the last 5. That is not a cube root in any way, shape, or form. And if you weren't paying attention, you might accidentally forget there's a difference between a cube root function and a square root function, and you're going to bound these last 5 to make a silly mistake and pick the wrong kind of function. Okay? So that's why I'm ranting. 11 through 15 are from 10.3, where there were no restrictions. And so you're going to be looking for a turning point, not an end point. H and K. Now it's still found in the same place. Here's H and here's K, but it's a -1, where it will be spinning. You know, if you put a pin in it and you twirl it like a pinwheel in the wind, it would be symmetrical around that point. So this one almost fooled me because it was supposed to be a -1. So A was a little, pretty close, wasn't it? Pretty close, and that's not the spinning point. Okay? So B we threw out because it wasn't a cubic function. C is very obviously not a -1, a -1. Then D looks almost like A, but if you go a -1, a -1, that's the turning point. And here's how you know it is D for sure, for sure, for sure. Test 0y. Test this point, like in this case, it's 0, 2. Test the y-intercept is what that's called. So in your little if you put a 0 in here, do we get a 2 out? So does 2 equal 3 times the cube root of 1 minus 1? Does 2 equal 3 times 1 minus 1? Does 2 equal 3 minus 1? Yes. Now that's what you do if you have two close graphs. So I picked that one because it was simple, you know. When the variable's 0, it's easy to pick, okay? But if you have one that's not very, you know, like, how do you know it's not A? Let me show you. See where that crosses? That crosses at 0, 4. So that's a no. We got a 2 out. We didn't get a 4 out. So that's to help you know for sure where that graph lies. That's 11's about the closest I could find where you are going to have to test a point, you know, to check to see if the graph you picked is right. That's being able to do that for any graph is huge. Huge, huge, huge. So 12. Mix the square root function, please and thank you. Read your equation. This is reflect across the x-axis. That's the negative part. The 3 makes it vertically stretch. Just like all the other graphs, and here we dig out the h is a 4 and the k is a -3. So we'll see if we need, we'll see if we need, boy, that's a booger. Calm down. There we go. We'll see if we need that vertical stretch idea, but just to know that you can see it. We're looking for 4 to the right, 3 down on a nice curvy road. 4 to the right, 3 down. D is looking, and it is going down, so that B, letter B, is looking good. So 4 to the right, 3 down. It's not the spinner. Turning point's up over here, right? You guys see that turning point? With your educated eyes, working on 10-3 enough? And then D, 4 to the right, 3 down, is way obviously not that story. So, okay. So if you're in doubt, it doesn't look like it's exactly on -2, but you can plug in 0, see what you get close out. You'll see that's not the truth. And if you test a point, what did we say? B was the winner? Because this turning point was at the HK where it should be. Okay, and it's headed down. And if I counted the verticals, I go down 3, 1, 2, 3 over 1. Yep, that point's on there. I like that one just as well as I like the testing a point. Okay. We got our bell back. Just don't have our clock back, huh? Oh well, that's okay. Okay, this one's a jumbled up mess. Got to rewrite it. So I see a -2 cube root of x minus 3 plus 1. I like to rewrite it so that h and k are obvious. So I have a 3 and a 1 and a reflect across x-axis and a vertical stretch of 2. So all these things you put in the, should go there, in the software for your homework so you can show up for this assessment and know what you're doing for sure. That's just those are just stars, just like these are the notes you would write. That's what I'm doing here. These are just noting my characteristics of my graph. So I have to go a +3, a +1. I'm thinking A is the answer, +3, a +1, B is way off, +3, a +1, C is off a bit, D, cross out, please. Do that first. I should have done it first. Get rid of that square root. It doesn't belong in the cube root story, so A is the result. It goes down. I go count 1, 2 over 1. That vertical stretch is true. If it wasn't true, I wouldn't land on the curve again after I counted down 2 over 1. Okay. How I knew what to do. H and K, no problem. No matter what side K is on, it's still K. It's what's being added outside the cube root story. The radical. Then I can cover all the topics. Okay? And last two. We're going to go reflect, stretch, -4, 1, +1. So this is tricky. -4, -1. Nope. See that -4 or +1 should be there. -4, +1. I'm thinking it's B. C. -4, +1. And D was a liar, liar, pants on fire. It's a square root function. Like, well, why would they put that in there? Because they think you don't know. That's why. So B goes downhill, and it's stretched 1, 2, 1. B is the answer. Did you do that? Sure, I'll find out, won't I? The test is the evidence of your understanding. No reflection. Yay. Stretch of 2 vertical. A -6, a -1. Get that grounded, guys. Get those grounded. I'm thinking it's A. Let's see. There's that. Make sure it's a stretch of 2. B. negative 6, negative 1, nope. C, negative 6, negative 1, nope. D is liar, liar, pants on fire. That wouldn't have been a tricky one, wouldn't it? If you were in the heat of the moment. It does have a negative 6 and negative 1 as the endpoint, but remember the last 5 are cube roots. Thank you. Be ready for the test. Are you feeling it?